Hello friends, I am Pratima. I welcome you all to my channel. I thank all the subscribers for supporting this channel. Today on the screen you may observe a question based on International Math Olympiad. The question is based on geometry, that is, let ABC be the sides of triangle and T is area. Prove that A square plus B square plus C square is greater than or equals to 4 square root 3 times of T, that is area. In what case does equality hold? So for this, let us take the help of the Heron's formula, that is, if A, B, C are sides of triangle, then S is the semi-perimeter A plus B plus C by 2. We know that area equals to T. I am writing here because it is given that T is the area. Square root S into S minus A, S minus B, S minus C. So I am writing this S in term of ABC. So I am writing T equals to square root A plus B plus C over 2 instead of AS. Here A plus B plus C minus A, and here A plus B plus C minus B, and A plus B plus C by 2 minus C. So if we will simplify, here T is equals to, I am taking 2 into 2, 4, 4 into 2, 16. I am taking 4 outside. So it will be A plus B plus C. If we will simplify this second term, this will be A plus B plus C minus 2 I say. So I am getting B plus C minus A. And here, if we will simplify, it will be A minus B plus C. And the last one will be A plus B minus C. Or T equals to 1 by 4. I'll make these two pair together. So this is B plus C plus A, B plus C minus A. And second one is, second pair will be A plus B minus C and A minus B minus C. So in the second step, I can write this. This is square root B plus C whole square minus A square, B plus C whole square minus A square, and the second one will be A plus B minus C, A minus B minus C. So this will be A square minus B minus C whole square. Or this T equals to 1 by 4. So this will, I am expanding this, B square plus C square plus 2BC minus C square, A square whole into A square minus B square minus C square plus twice BC. So this will be same as your 1 by 4 2BC plus B square plus C square minus A square, and the second one will be 2BC minus B square minus C square plus A square. So this equals to 2bc whole square minus b square plus c square minus a square whole square. So t is 1 by 4. Now I'm expanding again. So this will be 4b square c square. Second expansion will be minus b4 minus c4 minus a4 minus 2b square c square plus 2a square b square plus 2a square c square. So the ultimate result of t is your, in term of ABC, is twice a square b square c square plus twice b square c square plus twice c square a square minus a4 minus b4 minus c4. So this is a very important result we apply in many questions. Now after getting this t in term of ABC, now I am coming back to another relation, that is a square minus b square. We know that this is square, this is greater than 0. B square minus c square square is greater than equals to 0 since it is a square, and c square minus a square square is greater than equal to 0. And when they are equal, when a is equal to b is equal to c, this expression is equal. Now I am taking help of this expression to prove the rest result. So I can write a square minus b square whole square plus b square minus c square whole square plus c square minus a square whole square greater than equals to 0. Now expanding this, I'll get a4 plus b4 minus 2a square b square plus b4 plus c4 minus 2b square c square plus c4 plus a4 minus 2c square a square is greater than equals to 0. So I'm getting twice a4, twice b4 and twice c4 is greater than equals to twice a square plus a square b square. A square b square plus b square c square plus c square a square. Here I'm applying multiplying the whole thing again with 2, so that I'll get 4a4 plus b4 plus 4c4 is greater than equals to 4a square b square plus 4b square c square plus 4c square a square. Out of this 4, I'll keep a4 plus b4 plus c4 here on the left hand side, and I'll take 3 to right side. So here it will be 4a square b square plus 4b square c square plus 4c square a square minus 3a power 4 minus 3b power 4 minus 3c power 4. What next? Next is I'll add a4 plus b4 plus c4. I'll add a twice a square b square plus twice b square c square plus twice c square a square on both the sides. So on the right side I'll get 6a square b square plus 6b square c square plus 6c square a square minus 3 times of a4 plus b4 plus c4. So left side I am getting a square plus b square plus c square whole square. And in the right side I am taking 3 common. So when I am taking 3 common, I'll get twice a square b square plus twice b square c square plus twice c square a square minus a4 minus b4 minus c4. So what will be taking the square root? A square plus b square plus c square is greater than equals to square root 3 square root of 2a square b square 2b square c square plus 2c square a square minus a4 minus b4 minus power c power 4. It's not b4, it is square p square 4. Now what was this? If we'll remember the last result I derived, this is your 4 times of t. So instead of this I can write 4 times of t. So a square plus b square plus c square is greater than equals to square root 3 into 4 times of t. A square plus c square plus c square is greater than equals to 4 root 3 t, where t is area. I don't claim that this is the only method. If you have not read the higher trigonometry and if you are preparing for the Math Olympiad, you can proceed in this method. When they will be equal, we have already discussed. I have started from a square minus b square. A square minus b square is greater than equals to 0. So b square minus c square is greater than equals to 0. And c square minus a square is greater than 0. I started from this expression. That means this equality holds good when A is equals to B equals to C, or it is a equilateral triangle. Thank you.